These notes cover section 2.8, modeling with variation. The objectives are here on the right: solve direct variation problems, solve inverse variation problems, combined variation problems, and joint variation problems. So the first type we're going to talk about is direct variation. Direct variation is when one variable varies directly as the other. So here you would read this as y varies directly as x. The k is a constant, means it would be a number. That would look like a slope. So this would be a line with the intercept at 0, and it would have some numerical slope. K is called the constant of proportionality. It's the rate at which one variable varies with the other. Okay, next page. This is an example of two variables that vary directly with one another. When you swim underwater, the pressure in your ears depends on the depth at which you are swimming. So the pressure varies directly as the depth. The constant of variation here is 0.43. Pause the recording and take a minute to read over this example. Okay, the steps here show generally how we solve variation problems. First, you're going to take the words and write it into an equation, so something like this equation right here. The second thing is that you're going to substitute the given pair of values into the first equation so that you can solve for k, the constant of variation. The third step is that you're going to take the k and put it into the equation to solve for the second value from a second pair of numbers. Okay, let's look at an example. Turn the page. Example 1, the volume of blood B in a person's body varies directly as weight. A person who weighs 160 pounds has approximately 5 quarts of blood. So this is the first kind of ordered pair. And you start with the equation y equals kx here, okay, and put in 5 for x and 160 for y in order to solve for the k. Okay, so the steps below, that's what we're going to do in order to estimate the number of quarts of blood in a person who weighs 200 pounds. Okay, so like I said, we're going to start by writing the y equals kx equation. You can change this to variables appropriate to the problem. B equals kw. Substitute in the 5 and the 160 to get the constant of variation. Now that we know that that constant of variation is 0.03125, you go back to your B equals kw equation and put in the k equals 0.03125. Use that information, this equation now, to solve for B when the person weighs 200 pounds. Okay. Pause the recording here for a minute to read over this example and again look at how to solve this equation. It's kind of like a two-step part to solving this. So first you solve for the k, and then you put the k in to solve for the other variable you're looking for. Okay, pause. All right, the next page. The next example deals with direct variation of powers. So this is, instead of having y equals kx, we're going to have y equals kx to the n, so n has a power. So we would say y is directly proportional, or y varies directly with x to the nth power. Okay, here's an example. The distance s that a body falls from rest varies directly as the square of the time t of the fall. Okay, I'm going to pause here, write down the equation, write it with me, then we'll continue. Okay, so our equation is based off of y equals kx to the n. Using variables appropriate for this problem, we're going to say s distance equals k, that's the constant of proportionality, times time squared. Substituting in the numbers they give us for the first pair, if skydivers fall 64 feet in 2 seconds, so 64 feet in 2 seconds, so the time is 2 here. How far will they fall in 4.5 seconds? So we want to use this pair to find the constant of proportionality. So I get 64 equals k times 2 squared. That becomes 64 equals 4k. Divide by 4, and you get k equals 16. Now the next step is going to be to substitute that constant of proportionality back into the equation and solve for when t is 4.5. Okay, let's write that next. Okay, so taking the k equals 16 and substituting it back into the original equation, we have s equals 16t squared. We want to solve that for when t is 4.5. So we substitute in the 4.5. Multiply that out, and I get s equals 324. The unit is feet. So that is how far the divers will fall in 4.5 seconds. Okay, let's turn the page. Next topic is inverse variation. Two variables are inversely related or inversely proportional if they have this relationship, y equals k over x. So this is a rational equation. X is in the denominator. You have this constant, which is going to be a number, constant of variation on top. This is red. Y varies inversely as x, or y is inversely proportional to x. Let's look at an example of an inverse variation problem. Take a minute to read this problem. Pause while you read it, and then we'll go back together and solve. Okay, so we're going to start with our standard varies inversely equation. It would behoove you to memorize this and the direct variation equation as well. So start with y equals k over x. Next, write an equation that's appropriate variables for the problem. So I chose P equals K over V. So pressure varies inversely as volume. Then use the ordered pair that they give us to find the constant of proportionality. So we get when the pressure is 12 pounds per square inch, the volume is 8 cubic inches. So you have 12 equals K over 8. This is a proportion. Really where k is over 1. So you could cross multiply this and get k equals 96. That's the constant of proportionality, which is going to get plugged back into the original equation, P equals k over V. And then we're going to use that to solve for the pressure when the volume is 22 cubic inches. Okay, so we substitute in the 22 here. 96 over 22 is 4 4/11 pounds per square inch. Okay, turn the page. Next topic is combined variation. This would be for when you have multiple variables. Direct and inverse variation occur at the same time. So in this case, we look here, we have monthly sales S varies directly, so varies directly is the K here, as advertising budget. So varies directly, the A is going to be on top, and varies inversely as the price, so that means the P is going to be on the bottom. So let's look at an example of a combined variation problem. Pause while you read this. Then the first step is going to be part A, write an equation of variation that describes the situation. Let's do that. Okay, so the equation is the one from up here. Monthly sales varies directly as advertising budget and inversely as the price of the product. Okay, so that's part A. Part B, determine the monthly sales if the amount of advertising budget is increased to 70,000. So we need to use the pair that, or the trio of numbers that they gave us here, 60,000, 40, and 12,000 to determine the constant of proportionality. Okay, so we put 12,000 in here for the sales. That's from right here. 60,000 is the advertising budget. So that's from right here. Okay, goes in for A. And the price of the skates is $40. So that's the P here in the denominator. Okay, the next step algebraically is I divided 60,000 divided by 40, and that's 1,500. So we have 1,500 times K equals 12,000. Divide both sides by 1,500, and you have K equals 8. Okay, this is the constant of proportionality. Next, we'll plug this back into the equation and solve for when advertising budget is 70,000. Okay, so we take the constant of proportionality, plug that back into the original equation, which is right here. 8 is in for K. Then we want to use this to determine monthly sales now when A is 70,000. So I'm going to substitute in 70,000 for A here. The price of the product must remain the same because they haven't changed it, so that's still 40. And then you just multiply 8 times 70,000 divided by 40 and get $14,000. Okay, turn the page. All right, last type of variation is joint variation. This is like combined variation. It just has multiple variables, usually 3 or 4 or more. Joint variation is involved in Isaac Newton's formula for gravitation. Okay, so it says that the force of gravitation F between two bodies varies jointly as, okay, so G is the gravitational constant. Okay, that's the constant of proportionality. So varies jointly as the product of their masses, m1 times m2, and inversely as, so that means in the denominator, inversely as the square of the distance between them. All right, let's look at an example of a joint variation problem. Pause while you take a moment to read this problem. Okay, after you've read the problem, the first step would be to write the general equation. Let's start with that. Okay, so I've highlighted the variables that are important in the equation. We have centrifugal force C varies jointly, so that means you're going to have multiple variables, okay, varies jointly. So first of all, directly, with the radius R and the body's mass M. So that this gives me the C equals varies jointly and varies directly. We need that K here, always the K here on top, as the radius and the mass, okay, those are direct variants, and inversely as, so we need the fraction bar here, inversely as the square of the time, so t squared in the denominator, okay? So 1, 2, 3, really 4 variables. This is a joint variation. So the first thing you're going to do is plug in the variables that you do know in order to find the constant of proportionality, okay? So a 6 gram, let's underline this, 6 gram body, okay, that's the mass, so that goes here. Moving in a circle with a radius of 100 centimeters, that goes here. At a rate of 1 revolution in 2 seconds. Okay, so that's time is 2, that goes here, 2 seconds, and it's t squared, so 2 squared. Has a centrifugal force of 6,000 dynes. So the 6,000 is the C, the force. Okay, go ahead and multiply then 100 times 6, divide that by 4, and you get 150. Divide both sides here by 150, and you get K equals 40. So the constant of proportionality is 40. You take that constant and substitute it back into the original formula. So we're taking this formula, putting in 40 for K, and then we'll use that to solve for the next part of the equation. Okay, so the second part is here. Find the centrifugal force for an 18 gram body. Let's change colors here to green. 18 gram body, that goes here. Moving in a circle with radius 100 centimeters, so 100 is here. At a rate of 1 revolution in 3 seconds, so the time is now 3. Okay, so you simply plug and chug here, multiply these, divide by 9, and you get the force to be 8,000 dynes. All right, pause so you can catch up writing all of that down. Okay, and I'd like you to take a couple minutes to try to solve this problem on your own without guidance. Okay, this is my full solution for the checkpoint 5 problem. Take a minute to pause this, write it down and discuss with a friend. Okay, the Math Excel assignment for this is Math Excel 2.8. It is available online. I've also printed off copies so that you can begin to work if you have any class time left right now. You can start to work on it on paper. And then I will see you tomorrow. Have a good day.